However, I will be like going over especially the DeFi section, which is the foundational knowledge that you're gonna need for writing the hooks on Uniswap V4. Okay, thanks Teddy for posting this. Also, I did an office hours, a series of office hours on Uniswap V2, or more specifically, how you can create an automated market maker like Uniswap V2. I'll just go over the code here. The links we have the links in that README document. So basically, the way you can perform swaps is basically, you are buying token A by spending token B. So here we got WETH and DAI and USDC. This is on the mainnet, and this is the router. Router contract is the contract via which you will be able to perform the swaps. So there are a couple of combinations that there are multiple combinations which you can do. You can specify the exact amount that you want to swap for. You can also specify, multiple swaps as well. For example, you want to buy USDC for DAI, but you want to first swap DAI for WETH and then WETH for USDC. You can do that as well, which we call it here as the path. And then you can also specify how much amount that you want to buy. So if that's the case, you can say amount out, right? You can do the same thing in multi steps as well. For example, you want to buy some amount of USDC. So you here you don't specify how much DAI you want to spend in amount out. Okay, whenever you see a function that has got amount in, which means you are specifying the amount which you want to spend. So exactly this amount will be spent, and here you are specifying how much minimum amount you would like to get it, right? So what that means is if the amount is less than the minimum amount, the transaction is going to fail, right? I can see the screen share. I can share it again. So how about now? Yeah, I was sharing the screen. Okay, anybody else is having the issue seeing the screen?
Seems to be working on my end.
Teddy, I think there might be some issue on your end. Okay, this is how the router looks like, wherein you need to specify the path, and it is going to go to the specific pool and it will get the token, right? So if we talk about how the pool contract looks like, it looks, yeah, I should actually go here. Yeah, so if you have this link here, these are the workshops which we have done so far, and it's gonna stay as well. So it was a DAX, build a DAX is what we call, and we call it as Uniswapper. So this is how the pool contract looks like, where you can, add liquidity and you can swap token. And as I said, there are, four combinations here which you can do. For example, you want to swap for some amount A, exact amount A. If you want to swap token B for token A, so you will specify, token B here. So here we have given an analogy. For example, if you want to buy like 100 gram of chips regardless of the price, which means you want to buy some amount of token A regardless of whatever price token B is. Here, you want to spend $1 for any amount of chips. So which means that you want to only spend a fixed amount of token B for whatever token A that you'll be getting. Then another case is you would like to sell or you would like to buy any amount of token A for some fixed amount of token, but you don't really mind how much of token A you would like to get. You can specify the minimum amount, of course, but you don't need to specify it in the pool contract. This is the pool contract. You can specify that in the periphery contract, which you call it as the router contract. And then you can sell chips as per demand regardless of the price. You would like to spend this one, you would like to like spend all the amount of token A regardless of how much of token B you'll be getting, right? So this is the example of automated product market maker, right? We call it as the constant product AMM, or constant product type automated market maker. So it has the liquidity of token and token B. You can see we have got transfer functions. So depending on the amount of swaps of token and token B, the reserve will keep on changing. And of course, there is a fee part. So 0.03% of fee is charged for every swap, and these fees are shared as an incentive to liquidity providers. Liquidity providers are the actors who are going to add the liquidity, and as a result they will be getting the liquidity token, right? So this pool is itself, an ERC20 token as well, and this ERC20 token has another token A and token B, which is again an ERC20 token, right? Okay. So this is the periphery contract. I would like to test using Foundry. You can do it. How to use Foundry is already there here. Introducing the Foundry Ethereum Development Toolbox. You can go over it. If you haven't, please go through it. It would be great if you can just get over it, and also always try to watch the recording after we are done as well, or you can do both. Actually, whatever material that I'll be sharing, can go over that as well as recording after we are done with the session, because we just have like 1 hour, 1 hour of time, right? And we'll try to cover as much as possible, along with, of course, answering your questions. So this is swap for Uniswap V2, and this is remove liquidity. We have everything in our builder decks session, where we are explaining everything, whatever you see here. For example, you want to add liquidity, you want to remove the liquidity. Without liquidity, swap cannot happen, because if you want to swap coin A and coin B, then the pool should have requirement of coin A and coin B, and the amount of coin A and coin B is going to determine what is the exchange price for that, right? So by the way, exchange price for coin A and coin B are very easy. If you want to get token price of A in terms of B, then this is a formula. If you would like to get price of B in terms of token A, then this is the formula, right? So depending on how much amount of reserves this pool have, the price will fluctuate accordingly, right? All right. So there are also ways through which you can create a pool. The router contract has a function called create pool. So you can just supply your token address and you'll be able to create. Now, for example, if the combination of pool that you would like to create, if somebody already created it before you, then you won't be able to do it. That is on Uniswap V2. Okay. So there is it's like you have got a factory contract, and from factory contract you can keep on producing more and more pools, right? But the way they are taking care of is also very interesting. I can show you that. Okay, so this is Uniswap to router contract, and let me grab the factory contract. No, the factory contract is V2. Okay, here, this is actually a very nice tool. If you're on Etherscan, and if you just click on this IDE, it will open directly, so you'll be able to see the code directly here, right? But sometimes it might be ugly. It's okay. So here, how you are able to create a pair. Okay, so you need to pass token A, token B, for example, USDC and WETH. These are all the sanity checks, like how much, like you cannot have token and token B to be same. And then they are actually rearranging based on the ascending descending order. So because they use it in order to create the address, right? So this is a very interesting function which we call it as get pair. Okay, where is get pair is Uniswap V2 factory. What? They don't have it here. Okay, maybe it seems to be some issue with that ID, because if it is here, oh, sorry, my bad. I was actually looking something else. So this get pair is actually a mapping. So what they're doing is they are just checking if this token, or if you reverse the direction from token 1 to 0, is there some, you know, pool contract already attached with this token pair. So this is very important check. It should be 0. If it is not 0, which means there already exists pool contract which consists of this token and this token. So you cannot create. You cannot create duplicate contracts, basically, right? So once that check is done, what they're doing later on is they are deploying the contract. Okay, so the way that they are deploying the contract is by using create to. So using create to, you can very well, make a deterministic deployment, which means that even before the pair contract is deployed, you can literally compute what is going to be the contract address. That's the beauty of create to, because the way that it works is via the salt. The bytecode remains the same, right? The bytecode of the pool contract is going to remain the same. They are passing the salt. So the salt is actually concatenation of token 0 and token 1 address, and if you do a hash of it is what is used. So it can be done off chain as well. You will be able to calculate the pair. But anyway, so this is the way that they are calculating, so that it becomes very deterministic to identify that if given the token and token B, what the pair contract will be, right? So that's what they are doing. And yeah, so this creates a pair contract. So once the pair contract is created, then, you know job of the router comes in. You can, add the liquidity, remove liquidity, and other uh, other functions which you can do in. Okay. um, okay, so here is another example of adding one-sided liquidity. This gets a little bit complicated, because what happens is, if you are trying to add one-sided liquidity, you will have to, swap half of the token into token B, and that's how you will be able to actually add the liquidity. So that's what they call it as zap, wherein you specify token A, token B. So token and token B address needs to be specified so that it can identify which pool contract you are going to use. So this is why you need it, because you need this pool contract address, which we call it as the pair. They are naming here, the variable named here is the pair. So they are only adding like amount A, which is of token A only and not token B. So the way it works is, you will have to swap half of the amount of token A for token B. So once you have that, that's what they are doing. They are swapping. Once you are able to swap half amount of token A for token B, you will be able to add liquidity of token and token, right? It is a very classic example of yield farming. Okay. So if there is an opportunity wherein you want to add a liquidity, but you just have ETH with you, and you want to add liquidity to ETH USDC pool, then what you can do is just get some ETH here and just swap it out for half of the amount, and then you can just add the liquidity of token and token B, right? Yeah, so that's what will get you the swap amount. Okay. Yeah, and then when you swap, you will have to approve your token for router contract, so that router can spend your token and can, add, remove from the pool contract, basically. Let me see how are they working on it. So first they are transferring the token from user to this contract. Then they're trying to get the pair contract, and they're trying to get the reserves. And then, if token 0 is token A, then they're doing reserve 0 and amount A, which means they're going to swap token 0 to token 1. Else They're going to swap token 1 to token 2. So this will get you the swap amount. So next is now actual swap. This is where the execution of trade happens. So first, whatever amount that you pass will be approved. From is the token A. So token A will be, we are actually approving router to spend the swap amount, and we are specifying the path. So here what we're doing, we are swapping exit tokens for token. So what this function is doing is the exit amount of this amount, swap amount, will be used for swapping token A to token B. Whatever amount of token B that we're gonna get is something which will be held here. Address, this which you can see here, is the recipient address. So we are specifying that whatever the amount of token that we're gonna get after the swap should be received by this contract. So it comes here. So once this swap is done, we are adding the liquidity of token A and token B. So whatever balance of token A and token B we have, we are going to approve it to router, and then we're going to add the liquidity. So yeah, that's basically how we are going to add one-sided liquidity. So the swap amount which you see here is going to get you the optimal amount of token A that you should swap, and this is the math behind the same. Okay, now this math is actually based on constant product formula for the AMM. Okay, now we know that x y equals k should be there. So in whatever proportion the token x is going to increase, in the same proportion token y should increase. If that's not going to happen, the add liquidity, which we are calling here precisely this point, the transaction will fail, right? Why the transaction is going to fail, that is actually involved inside the pool contract. Okay, so if I just show you here, we are calculating. So when you are adding the liquidity, we are getting the geometric mean, right? So the geometric mean is actually the square root of the amount of token, the optimal amount of token A times token B minus the minimum liquidity. So the minimum liquidity that we should have here is this 10 to the power 3. This is something which is set by Uniswap protocol, that you should have this much amount of minimum liquidity. It should never be zero, right? So now if you want to calculate the amount of A and B such that this particular case will not fail, then we need perform the square root. I mean, it's the same thing which I showed you. We will have to basically calculate the optimal amount, right? So given the reserve, we know that if we have got this much amount of token A, from this amount, how much of token A should be swapped for token B so that the pool contract is balanced. Okay, so that's what we're doing, and that's how we sort of add the liquidity to the router contract, right? Yeah, it's all the constant product formula that should always suffice. Okay, next is what else you need to know. Remove and add liquidity is optimal. It's okay if you are not paying attention to this guy, it's all fine as well. I just saw it and I just wanted to relate it. And then we have got Uniswap V3 swap. So Uniswap V3 focuses on the concentrated liquidity. What does that mean is, if we take a look here, let's say we do a swap. Okay, so there is only one pool contract for a given token pair. Okay, so let's do. Okay, so what happens is, let's create a table. Actually, I should go. I'm just gonna do it in the sheet. It's gonna be more easy for me. Okay, so now you have got some token A, got token A, you got token B, and then you got pool contract, or you can just say LP token. So LP token is combination of token and token B, and then here we have the fee. Okay, so when it comes to V1, right? Let me just put it here. So this is, sorry, not V1. This is Uniswap V2. Okay, so this is Uniswap V2. The fee is flat at 0.03%. Okay, for example, you have got DAI and you have got WETH. You will be creating an LP token called DAI WETH, right? Okay. So now if you want to create another LP token contract of DAI and WETH, you won't be able to. Okay, but if you want to create of DAI and USDC, you will be able to. The fee is constant at 0.03%, which means that if you are swapping through Uniswap V2 and the pool contracts that are created out of Uniswap V2 factory, then for every swap you will be paying 0.3% fees, as well as whatever mint fees, burn fees that you will be earning as an LP provider. So I'm talking this from the perspective of a trader, not from the perspective of an LP provider. Okay, so let's just view from the perspective of a trader, just to make it simple. Okay, all right. So you can just keep on going with whatever combinations that you can, and there are like tons of pair contracts created in Uniswap V2. You can check the number of pairs by just going into Uniswap factory contract, and there is a variable called pair length. So you can just do that. Now, what happened in Uniswap V3 is they wanted to have much more option for the trader on choosing, or rather for the liquidity provider on choosing the fee tier. Okay, so they came up with some fee tiers there, and they are hard coded at three. There are three fee tiers with different values, which is also hard coded. So I'm just going to merge. Let me name it as Uniswap V3. Okay, and here, so they came up with fee tier 2 and fee tier 3. Now just keep that in mind. The factory contract for Uniswap V2 is different than V3. Okay, but just for the simplicity, I'm showing you that it only had fee tier 1, just one tier for Uniswap V2. If you don't understand, just let me know. And I think they came up with 0.5%, and yes, 1%. I should actually confirm that from Uniswap V3 docs. Okay, so let me go to the concepts, protocol, concentrated liquidity, and fees. Yeah, so 0.05, 0.3, and 1%. So 0. Okay, my bad. This is 0.3, not 0.03. And then there is another tier of 0.05. Just some zeros here and there. And so you got P tier 1 of 0.3, 0.5, and then, yeah, 1%. Okay. So what does that mean here? If you can see, token A and token B for Uniswap V2 is just one pool contract which has flat fee of 0.3%. However, when the same pool is created with respect to Uniswap V3, then the liquidity provider has got three options. Okay. First option is whether the liquidity provider would like to add into the pool wherein the swap fees are 0.05% or 0.3% or 1%, right? So what does that mean is if a trader is going to swap DAI for WETH in Uniswap V3's fee tier 1, I should just call it as fee tier 1, and this is 0.3% is flat fee for Uniswap V2, but it is fee tier 2 for Uniswap V3. And then, yeah, so it depends on the trader. So the trader has now a choice, which means that the liquidity in the pool is now concentrated. So if this particular P tier pool will be charging 0.3% for the same token A, token B, right? Whereas another pool will be charging 0.05% for same token A, token B, right? So what did Uniswap V3 introduced is multiple pools for each token pair, whereas Uniswap V3 only had one pool for one token. Uniswap V3 has at most three pools for one token pair in three different fee tiers. Okay, so as a trader, like which one to use, right? So there are, certain type of assets that is going to gravitate towards specific fee tiers based on, where the incentives for both swappers and liquidity providers can come nearest to the alignment. What the Uniswap guys were expecting is the low volatility assets like stable coin will likely congregate in the lowest fee tier. Okay, now again, this is what their expectation is. So the one that has got low volatility will be in the lowest fee tiers, as the price risk for the LP holding this assets is going to be very low, and those swapping will be motivated to pursue an execution price which is closest to the same one-on-one as they get. And they were expecting of more exotic assets which are traded very rarely, are going to naturally gravitate towards a higher fee, because the LP will be motivated to offset the cost risk of holding these assets for the duration of their position. Okay, so that's the background for Uniswap V3. Similarly, for as we saw in the V2, V3 also has the router. However, when it comes to the swapping, you will have to supply an extra parameter, which is known as fee tier, because if you specify the fee tier to the router contract, that is how the router contract would know on which pool contract to access, right? So here, the example to swap between wet and dye, right? This guy would like to swap this much amount of wet for any amount of dye, but the minimum the user would like get is this, right? So what they do is they are going to get the wet from the user's account to this contract, and of course you need to allow router to spend the wet, and then you are creating the parameters. So the input token is wet, output token is dye, the fee tier which you are accessing is 3000. So this 3000 means it's zero point 0.3, it is the basis points. All right, and the basis points is how we write down the percentage in finance. All right, when you say that the interest rate went down by 25 basis points, so what that means is the interest rate went down by by 0.25%. That's what 25 basis points means. Okay, now the basis points in finance is something like 10 to the power 2. So this means 0.25% in finance. Okay, here you are seeing 3000. I'm going to go over all the questions which you have posted. Here you are seeing 3000. Now this 3000 actually means is 0.3 percentage. The reason being, instead of multiplying it by 100, Uniswap is actually multiplying it by 10,000. Okay, so if you want 1%, okay, 1% to be represented in basis points that Uniswap, according to the Uniswap standard, then it is going to be 110 to the power 4. Okay, now if you want to represent 0.3, that will be zero point 0.3 means you are sort of just multiplying 3 by 1000. Okay, now instead of fee tier of 0.3, now if you wanted the fee tier of 0.05%, what will be the fee that you will be passing? Anybody? Yes, so it will be 500 exactly. And if it is 1%, it's 10,000, right? I have already written. So 0.05% means you will be passing 500 here as per the Uniswap standard. The reason that they are using it is avoiding any, can say, floating point issues. because it's percentage. All right. Same way, you can specify which amount exit outputs. Yeah, so you can also specify what amount that you would like to get, right? So here it means that you want to buy this much amount of DAI with whatever amount of VAT. However, you are putting up a condition that you don't want to spend more than this amount. So you are limiting your amount of VAT that you will be spending, right? So when it is going to actually execute the trade, it might happen that it may not spend entire amount of VAT. So whatever amount is remaining will be transferred back to the user, right? Okay, and this is the example of multi-hop wherein you can specify path here, right? And you need to encode it. So this is also a very interesting way that the Uniswap V3 router's exit input function will be decoding your path, and it will identify how many paths are there and which path will it access. So this what does this mean? It means that swap VAT for USDC in the fee tier of 0.3%. Then once you have the USDC, use another pool to swap USDC for DAI with the fee tier of I think this is 0.1% or 0.01%. Okay. Actually, there is no such pool in Uniswap V3. I think it's a typo. We have got 0.3%, 0.05%, and 1%. So 1% means 10,000. But yeah, it's, or maybe why they are using 100? Because 3,000 is 0.3% and 1% is 10,000. Okay, maybe it could be typo. All right, so this is Uniswap V3 swap and Uniswap V3 liquidity. Next class, in the next office hours, we will be looking into some of the concepts that you need to know. Like, what are the concepts that you need to know? Okay, say for example, concentrated liquidity, which I was talking about. It is there in Uniswap V3 book, and it is the prerequisite that you had to read it. You will be finding it in the prerequisite document, basically. Okay, so what this graph is showing, this graph is showing at this particular price, what is the price of ETH and how much of ETH is locked. Okay, so the graph was taken when the ETH price was around 6,000 US dollars, and like if you want to spend $1, then how much? I mean, yeah, it is going to give you the price at this particular tick. So this tick is something which we will be looking in our next office hours. So basically, when it comes to Uniswap V2, there was a problem wherein the in Uniswap V2 pools is distributed infinitely, which will allow trades at any price from 0 to infinity. Okay, because the way it's gonna work, we have minimum liquidity requirement. So what will happen is the price of token A or token B will never go to 0. Okay, it will be always, there will be always possibility of the prices going towards infinity on either axis, right? But it makes the capital inefficient, and according to some historical prices of an asset, if it is stays within some defined range, um, uh, I mean, historical prices stays within some defined range. It could be narrow or wide. For example, the historical price range of ETH is from zero point 0.5. So there was a time when ETH was available for 75 cents, and it has gone to 4,800. When this article was written, it is like 1,800. It was 1,800. So no one would buy one ether at 5,000. So it makes no sense to provide the liquidity at this price. So what they did is, it does not make sense to provide liquidity in a price range that's far away from current price. Or that will never be uh, never be reached. So they came up with concentrated liquidity. I already shared that there are got fee tiers, so you have an option on liquidity providers have an option on which fee tier pool they would like to add the liquidity. So LP liquidity providers can now choose the price range they want to provide liquidity into, and this is going to improve capital efficiency by allowing to put more liquidity into narrow price range. That will make Uniswap more diverse, and it can now have pools configured for pairs with different volatility. So V3 pair are like small Uniswap V2 pairs. You can put it that way. And the main difference is there are many price ranges in one pair, and each of these shorter price ranges will have finite reserve. This means that there will be some traders who are just going to focus on certain fee tier pools. Not everybody is going to focus on all of them like proportionately. So that will create different prices on different fee tier pools, and which means that entire price range from 0 to infinite is split into shorter price ranges, which are which you can get it by looking at like different fee tier pools, right? So this is what the graph looks like. We don't have a lot of time, so I will not be talking about it right now, but yeah, definitely go over this link which I'm sharing you. If you just go to this prerequisites doc, just go over this, because this is where your transitioning to V4 is going to start. Concentrated liquidity and mathematics of Uniswap V3. Okay, I'm going to take up some questions. I'm not sure if I'm supposed to be on this call. Yeah, if you have just started on Monday, what you can do is Eddie has posted a link in the very first chat. If you don't have that uh, here, I'll just post it. You need to go over all the links which I have specified here, and even if you have just joined Monday, you still should be good. I have to do a little bit more work than others, but our next office hours will be like 1 week from now. So I've got ample time to go over. Okay.
Uh, okay. Can I ask some questions? I started based on the curriculum that you guys have laid out on the course on
Hmm.
Metana.
Hmm.
So it seems like it's a long way from here. I mean, I can understand the syntax as you're going through them,
Hmm.
although I have not worked with these contracts yet.
Hmm.
So I'm not sure what you're saying. You're saying the office hours are going to be covering these topics from here on out, and everyone that just started the Solidity course just has to get up to speed with this, or I'm not sure I'm following.
We basically discuss about any trending topics out in this space, technical topics which are in this space. Of course, like you definitely will have to follow the curriculum on LMS religiously. Um, Office hours are meant for students to get their questions clarified if they have any. But if they don't have, then I don't want to sit and just spend 1 hour without doing anything. So what I do is I just keep a backup of topic which I have, right? Because yeah, that's what it is.
I see. So we're not necessarily covering topics on each assignment or
Yeah,
module that we go.
so
You just
office
okay.
hours are not mandatory, right? But I would say you should attend office hours. You'll get something out of it. So just consider office hours are extra learning. Just put it that way. Extra optional learning. Yeah, you can put it that way. Okay, our mainstream is of course on LMS. Office hours are meant for any blockers that the students have, but there might be cases where students are there in the office hours but nobody has any questions. So I don't want you guys to just look at me and spend 1 hour, right? It's better we sort of use this time.
Okay. I was completely not in the loop how you guys do things. So I was
Yeah.
under the impression that we were gonna cover topics per
So
module, but now I get it.
yeah, if you are just started this boot camp, then what I would suggest you is yeah, just go over maybe this guy's conceptual prerequisites, and this guy's is like try to finish that this thing. So this is solidity by example. Here they are teaching you right from the basic. Of course, we have like very detailed, lessons on our LMS, but this particular series of office hours is for everybody who is like new to solidity. We actually started right from the basics. If you take a look here, like last time I actually started from Hello World contract. Okay, so yeah, right. This is just specific to Uniswap. Okay, Uniswap has introduced a new version. It's not yet in production, so we cannot include it in, um, you know, in our curriculum because it's not production. Anything breaks, it won't be. But I can do it in real time. I can utilize office hours for that, so that's what I'm doing. Yeah, had no confusion. Yeah,
No confusion.
all right, awesome. Not sure. I think no worries. Um, Learning solidity is not difficult. Writing solidity is also not difficult. Um, you can learn solidity in like 4 hours. Okay, if you just binge watch those uh, YouTube videos which we have shared with you, it just take 4 hours and you can write literally anything in solidity. Okay. Challenge is in security and testing, right? That's why that's what we do here in this bootcamp. Need to see contract because it's only the interface. Which one were you talking, Teddy?
Think that last one you show it the get pair, I think. Show that the concept is interface, but I think that
Okay,
is
it's
yeah.
a very good example of how you can get an interface out of a mapping. If you have a mapping and if you would like to access that mapping from a contract, then you need to have an interface for that. So a public variable will be having a getter function. How you gonna read it? So that's what it was showing there. Um, have you ZipSwap that implements this feature? Only input it and you can get a yeah. V3 will give us NFT as LP token. You are right. NFT, yeah, it will have all the details regarding what was the fee tier that you use your tick value, and of course the token in token out. Um, for decimal points precision is what is being used for representing percentage in Uniswap V4. That's right. Um, they are using 4 decimals to just increase the to just decrease the error, right? Um, if you are dividing, uh, if you are dividing, 1,000 by 20, and if you are dividing 10,000 by 20, the error due to precision loss is going to be decreased, right? Um, that's the reason. You can like some of the protocols also use 18 zeros instead of 4 for percentage so that they can have like more precision. So concentrated liquidity, constant product is an asymptote. So concentrated liquidity can make it go to 0. Concentrated liquidity can make it go to 0. Yeah, so that's like the math that we'll be going over in our next office hours. But yeah, I think I don't want to give you that answer right now about how the liquidity can go 0, and how and why the liquidity is not going to 0 in Uniswap V2. Okay. Hey Fabrizio, I think we are like done, but yeah, you can watch the recording. Um,
Hi, Dravin. Hi.
okay. Next question is why use multi-hop versus single hop, and why not always specify to use the lowest fee tier? As a trader, it depends. Like if a pool contract is available in the fee tier that you would like to swap in, sure. But if there is no fee tier which you would like to do it, you will be forced to use the tier in which the liquidity is there. Of course, you don't want to go to a pool which does not have any liquidity, regardless of fee tier, right? I use multi-hop versus single hop. For example, you want to swap DAI for USDC, but there is no pool pair contract of DAI USDC. There is DAI ETH and ETH USDC. So you only have an option that you get ETH for DAI from DAI ETH contract and then swap ETH for USDC from ETH USDC contract. So if that's the case, you need to do multi-hop. Okay. It's the routing which needs to be done. Do the different fee pools create arbitrage opportunities? Yes, they will be creating arbitrage opportunities. However, you need to see whether it is going to make you a profit or not, because there are a lot of parameters that you need to see before doing arbitrage. The gas cost, because not only you are competing for that opportunity, there will be other bots as well who are going to grab that opportunity. So you'll have to see whether you will be able to get enough profit out of it to bribe the MEV. What about different instances of Uniswap protocol also arbitrage opportunity? I think I didn't get that question.
I was just asking, because so Uniswap is a protocol and it can be implemented, like there can be multiple, but on a, even I guess there can be
I
multiple
got it.
instances of it, right?
Yeah, I got it. Uniswap V2 is that is possible in Uniswap V2. In Uniswap V3, I think they have got some stringent licensing to the code base, and I think you will not be able to do it. So Uniswap V3 core has some got some licensing restrictions that will not allow anybody to basically copy the code, if that makes sense.
Does make sense. Yeah, I
Yeah,
appreciate the answer.
they have got the BSL license, Business Source License 1.1. But you can only do non-production use. Okay, BSL license gives you right to copy, modify, create, create derivative works, redistribute, and make non-production use. That's what BSL states. So it's a BSL license. So I mean, if you're caught using their code to do production stuff, I think they can, drag you to the code. I don't know about the legal aspects, but that's what it says. If you talk about Uniswap V2, what's up with Uniswap V2? I think there is a license. It's a general public license for Uniswap V2, and you see ApeSwap, Sushi Swap, they are all forks of Uniswap V2 because they are allowing Uniswap V2. You can have multiple instances. It's new general public. So you have permissions for commercial use. ESL license, you don't have permission for commercial use. Yeah, that's right.
Makes sense.
Okay, I think I'm done answering all the questions. So we're gonna end the call and see you next time. Bye for now.
Thank you, Lovin.
Norris, bye.
Bye.